Right now, a robot the size of a car is parked on a beach. There's no water. There hasn't been for about 3.5 billion years. But the sand remembers. This is Jezero crater on Mars. And the mud this robot has been drilling holds what NASA calls a potential biosignature. The strongest hint yet that this dead shoreline may once have been alive. This is the story of how a blue world turned red. For centuries, Mars was the planet most likely to be alive. Astronomers mapped canals, imagined vegetation. Then, in July 1965, a probe called Mariner 4 flew past and took 21 grainy pictures. They showed craters, a surface like the Moon's, under an atmosphere 1% as thick as ours, at 100 degrees below zero. Engineers were so impatient for the first image that they printed the raw numbers on paper strips and colored them in by hand, with pastel crayons from an art store. The first picture of Mars ever shown on television was a paint by numbers. What it showed broke hearts. The New York Times ran an editorial titled simply, "Dead Planet." And that verdict stood for 6 years, until Mariner 9 became the first spacecraft to orbit another world, waited out a global dust storm, and watched something impossible emerge from the settling haze. Volcanoes 3 times the height of Everest, a canyon as long as a continent, and dry riverbeds. Branching, sinuous, unmistakable. The dead planet had a watery past. So rewind 4 billion years to the world those riverbeds remember. The best supported picture looks like this: a northern ocean, Oceanus Borealis, filling the lowlands that today stand empty. Scientists still argue over its shorelines. They don't sit level and the maps disagree. But in 2025, a Chinese rover's radar found what looked like buried beaches beneath the northern plains, layer after layer of sediment sloping toward that vanished sea. Here at Jezero, snow on the crater rim melts into rivers. The rivers pour through a breach in the wall and build a delta into a lake 45 kilometers wide. The sun overhead is smaller than ours and paler, a colder star over a younger world. This is not Earth. The sky is milky, the light is thin, but water moves, waves break. On the shore where the robot now sits, there is surf. Every world like this needs a shield. Mars had one, a magnetic field, generated by its molten, churning core. And then, sometime around 4 billion years ago, scientists still debate exactly when, the core quieted and the field died. Stand on that shoreline as it happens and you'd notice nothing. No explosion, no darkness. The waves keep breaking, the rivers keep running. But high above the surf, something has changed forever. The planet's armor is gone, and the sky has sprung a leak. From that moment, every gust of the solar wind, the storm of charged particles pouring off the young sun, strikes the top of the atmosphere directly. Mars has begun to die. It just doesn't know it yet. We know because we've watched it happen. NASA's MAVEN orbiter has measured the solar wind stripping Mars's atmosphere today. About 100 grams of sky every second, torn away into space. Kilograms per second when a solar storm hits. Run that backward under a younger, more violent sun, and the models say most of the ancient atmosphere was lost overhead. The ocean didn't boil in a day. It retreated for hundreds of millions of years. The air thinning, the shallows freezing, the rivers giving out one by one. And as the water withdrew, the planet rusted. Here's the strange part. The red dust that colors Mars appears to be a waterborne rust. a mineral that only forms where cool water still lingers. Mars turned red while it was still wet. The color of the dead planet is a fossil of the living one. Twice we thought we had the answer to the obvious question. In 1976, the Viking landers, the first machines to land on Mars, carried experiments designed to detect life. One came back looking positive, but the instruments found no organic molecules at all, and the consensus settled on chemistry, not biology, reactive soil mimicking a living response. Then, in August 1996, scientists announced that a meteorite from Mars, a 4-billion-year-old rock found in Antarctica, held what looked like fossilized microbes. The President of the United States announced it from the White House. Worm-like shapes, bacterial minerals, organic residue, 4 lines of evidence. Over the next 2 decades, every one of them fell. Each had a plausible, non-biological explanation. The microfossils were too small for known cells. Not a hoax, science correcting itself in public. But NASA was burned. And that is why, today, the agency speaks in one carefully chosen phrase, and never past it. The phrase is potential biosignature. In 2024, Perseverance, the robot on our beach, drilled a mudstone called Jezero Falls in the dried river channel feeding the delta, and found something that made the team stop. Leopard spots. Pale dots ringed in dark halos, laced with organic carbon. On Earth, spots like these can be left by microbes feeding on the chemistry of wet mud. Chemistry alone can also make them. That's the fork. And this time, NASA held the line the 1996 team crossed. A potential biosignature, they said, with non-biological explanations they cannot yet rule out. But the evidence kept coming. In April 2026, Curiosity, half a world away, pulled 21 organic molecules from a single rock, 7 never seen on Mars before, including a ring-shaped molecule from the same chemical family as the precursors of DNA. And in June, hundreds of new measurements confirmed complex organic matter spread across the ancient riverbed at Bright Angel. 2 craters, 3,500 kilometers apart, telling the same story. The ingredients were everywhere. Which leaves the question this whole story turns on. Where does an ocean go when a planet dies? The obvious answer is up, stripped into space with the rest of the sky. But it may be the wrong one. Models suggest that much of Mars's water, perhaps most of it, never left at all. It was pulled down into the rock itself, locked molecule by molecule into clay. And seismic data from the planet's interior is consistent with something stranger still. Liquid water, sealed in fractured rock, kilometers beneath the surface, though scientists still argue over that reading. Mars didn't lose its ocean. It buried it. Walk the delta today and you'd find 10 titanium tubes laid out in a careful zigzag on the sand, drilled, sealed, and waiting. Inside are the cores that could finally settle whether this beach ever held life. Settle it in laboratories under instruments no rover can carry. The mission to bring them home keeps slipping. As of this year, there is no funded plan to retrieve them. 60 years ago, we called this planet dead and closed the case. The case is open again. And the answer may already be sitting in a tube on the last beach on Mars, waiting for someone to come back for it.